Well, hello chemistry fans. So this is just a video just showing out the worked out solutions to midterm number 1 questions. And so the first question, physical change. What we're looking for here is if it's physical, that means you have the same substance before and after the change. And so, sugar heated into caramel, that's a chemical change because you're breaking sugar apart. Iron rusting, you form a compound, which is iron oxide. So that's chemical change. Propane, when you burn a fuel, you're getting like CO2 and water. So something different than what you started with. So that's chemical. And then switching down to this one, so glucose convert into energy. So again, you're breaking apart glucose. So that's chemical. And so the only one where you have water before and after the change is if you're evaporating. So you just have liquid going to gas. And it's still water, right? It's the same substance. So that means it's physical. Okay. An element cannot, and so by, I guess, just definitions here. So an element can't be separated into other substances by chemical means. You can have a homogeneous mixture of elements. For instance, alloys, are homogeneous mixtures. And you could have a heterogeneous mixture where you have like elements compounds. We know that elements do interact with each other to form compounds. That's also a true statement. Here we're looking for the false one. And an element is a pure substance. And so the only one that makes sense here is that you can't separate it by chemical means. Okay. This is a unit conversion. So if you have 0.8500 kilograms and you want to know grams, we can set up a little conversion factor here. Okay, where kilograms on the bottom, grams on top, so that cancels. Then we can say that 1 kilogram is 1,000 grams. Okay, or in other words, we're going to move this decimal 3 places to the right. Okay, so that's 850.0. All right. Isotopes. And so all you're looking for here is really something with the bottom number the same. Okay, so that's literally how easy it is. So 1 and 3, the bottom number or atomic number is the same, and the top number, the mass number, differs. Okay, so that's literally it. So looking for isotopes, just hone in on those where the bottom one is the same number. This one, so we have to do the natural abundance, and so we're given 2 isotopes, what their atomic mass is, and then what their abundance is. And so here we do a weighted average, and so we would do 0.6011. That's another way to put percent, right? You're just dividing by 100, times 68.9256 U, and then we add in the other one, which is 0.3989 times 70.9247 U. Okay, and so that, if I punch it in my calculator here, 6011, 256. So this first one is 41.43, I guess, 12 plus 0.3989 times 70, 9247. That's 28.2919. Okay, so you add those together and you get 69.72. Okay. Protons, neutrons, electrons. Okay, so if this is a neutral species, which it is, it doesn't have any charge, then this bottom number will equal the number of protons, and that will also equal the number of electrons. Okay, so we're looking here for the same number. So 29 protons, 29 electrons. Okay, so that one's out, this one's out, that's gone, and that doesn't make sense. So I guess just with those alone, we know that it's that answer. Okay, then to get the neutrons, it's just the top number minus the bottom. So neutrons would be 65 minus 29. So that is 36. Okay. How many hertz is 600.11 megahertz? And so remember, if we have hertz in the middle, and then a factor of 1,000 is kilohertz, 1,000 times bigger, and then we've got megahertz, which is another factor of 1,000 times. Okay, so if we have 600.11 megahertz, okay, so set up a little conversion. Okay, where 1 megahertz is 1 times 10 to the 6th of a hertz. Okay, so you've got a factor of 1,000 and another 1,000. And so that is 600.11. And then if you want to do it this way, like you're going to move the decimal 6 more places, so that's 1, 2, 3, 4, 5, 6. Okay, and then scientific notation would be 6.0011 times 10 to the, now you're going to move it all the way from here. It's 1, 2, 3, 4, 5, 6, 7, 8 places. Okay. All right, this one, so if I write it out here, so 208 lead goes to something, and then 204 mercury. If I look at a periodic table, so let me open one up here. I guess I should have had this open before. So this is the one that you had on your exam. Okay, so we've got lead is element 82. So that means this bottom number is 82. And then it's going to mercury. And so mercury is 80. Okay, so the bottom number over here is 80. Okay, and so we want something that is really 4 on top and then 2 on the bottom, right? Because 80 and 2 have to equal 82, and then these two have to equal that. Okay, and so from your notes, the particle that has a 4 on top, 2 on the bottom is helium, or an alpha particle. Okay, which is not an ionic compound. So ionic compounds, you're going to have a metal and a non-metal. So something way on the left of periodic table, so something way over here with something way over here. Okay, and so you're looking for something that, here you've got a metal, non-metal, this is metal, that's a metal, that's a metal, that's in the middle, a transition metal. But here you've got phosphorus and chlorine. And so both of those are nonmetals, and so that would be a molecular compound, not an ionic. Okay, so this is molecular compound. All right, and then this, potassium, that's in group 1, so that's a metal. Chlorine is in group 17, so that's a nonmetal. So just again, some definitions there. The ion that nitrogen would have, okay, so if we look at nitrogen, It is 3 away from a noble gas. So nitrogen can take a 3 minus, okay, but it also sometimes can lose 5 electrons. And so that would be 1, 2, 3, 4, 5 to get back to helium's configuration. So really nitrogen can be a 3 minus or 5 plus in theory. Really nitrogen, like we're talking about all the elements in that group, group 15. Nitrogen, really the only one it can form in compounds is this one. Looking at kind of loss and gain of electrons, this is kind of a possibility, but in reality only the lower elements in that group, like phosphorus, arsenic, etc., they can take this oxidation state. Okay, so 5 plus is not an option on here, so the only one that made sense is this 3 minus here. Okay, so some definitions again from the metric units. So milli is 1,000 times smaller than its base unit, and we already looked at mega in another question, so that's a factor of 10 to the 6th larger than the base unit. Okay, so this is like an imperial metric conversion, and so we've got 240,000 miles, and you want to know kilometers. Okay, so this is kind of tricky. Okay, so the first thing I would do, you're given miles to meters, so let's use that. Okay, and then you want your answer in terms of kilometers. And so let's do one more. Okay, and so this is 1 mile is 1609, and then 1 kilometer is 1,000 meters. Okay, so basically it's 240,000 times 1.609. Or in other words, you're multiplying by 1609 and then dividing by 1,000. So that's 386,160, or in scientific notation, 3.9 times 10 to the 5th. Okay, now getting into some names. So copper is in this middle group. So you have to use, it's right here actually. Okay, so you have to use Roman numerals. Okay, and then this is one of those complex anions from that table in chapter 2 PowerPoints. So that's the chlorate ion, an anion really, a negatively charged ion. And so if chlorate is a -1 charge and you have 2 of them, that means that copper has to be 2 plus, right? So in other words, just to be a little explicit here, okay, this whole side, if this is -1 and you have 2 of them, this whole side is -2. So that means this side has to be +2. So that's why it's copper 2 chlorate. Okay. This one, so they're both nonmetals, so we need prefixes for both of them. So it's dinitrogen pentoxide. Okay, so pent because you got 5, and the di is 2. This one is sulfur monoxide. Okay, you don't say monosulfur monoxide. Okay, so it's kind of analogous to carbon monoxide. Group 2 are the alkaline earth metals, so just a definition question for you. Elements in a column, that is a group. Okay. A period, that's a row. Okay. This one, so it's kind of the base one that I told you, it's probably easiest if you remember anything with an ATE suffix. So that's chlorate. If you add 1 more oxygen to it, it's perchlorate. If you take 1 oxygen away, that's chlorite. And then if you take another one away, then it's hypoite suffix. Okay. This one, another nuclear reactions. This again with an alpha particle. So this whole side equals 242 on the top and 94 on the bottom. Whoops. How do I go back here? Not just erase. Okay. I guess you're adding it up, yeah. So you're reacting this with an alpha particle. So that means, here, if I rewrite it, maybe, we've got a 4,2 helium plus something goes to, this is a neutron. Okay. All right, so this whole other side actually has to equal 242. And so that means this has to be 238. Okay, and then the bottom one has to be 92 because both have to equal 94. Okay, and then you look in the periodic table for which element is 92, and that is uranium. Okay. So composition constant throughout, and that is a homogeneous mixture. Okay, if it varies throughout, then it's heterogeneous. So which form anions? So these will be ones that are close to the noble gases. Okay, so C and D. Okay, these will form cations, or positively charged ions. Okay, this one, so sig fig, so you're going to do this first, and it is subtraction. And so you're going to be limited by the smallest number of decimal places. And so let me just punch it in to the calculator. So it's 433.621 and then 333.9. And so my calculator gives me this. Okay, but you're limited to one decimal place. So it's really 99.7. And then that carries on to the next step of multiplication. Okay, so now if you do that, so 99.7 times 11.9, my calculator is 1186.43. Now we're limited to 3 sig figs. Okay, so I would do it scientific notation where it's 1.19 times 10 to the 3. Okay. Another similar type of question. Now you're going to do multiplication first, so you're limited to 4 sig figs for this first step. So let's do 965.43 times 3.911. So my calculator gives me 3775.79673. Okay, so to 4 sig figs, it would be 3776. And then you're going to add 9413.4136. Okay. And so now this, you're going to be limited to 0 decimal places. Okay, so when you add these up, 9413.4136. My calculator is 13189.4136, but we don't have any decimal places, so it's really just 13189. Okay. The X, so this is a real easy one. So here, just look, what's the bottom number is 35, and look what element 35 is, and it's bromine. So that's it. Strontium hydroxide, so this is recognizing that it's that. And then strontium has a 2+ charge because it's in the second group here. Okay, right there. And so that means to balance the charge, you've got a +2 and then a -1. So you're going to need 2 of those hydroxides. Right? So now you've got, each of these is -1 and you have 2 of them. So this whole side is -2. That's +2, so everything balances. Okay, number of protons. So just by definition, this is atomic number, which is incorrect. Okay, so this is nitrite. Okay, and so nitrite carries a -1 charge, and you have 2 of them, so that means that it would be manganese with a 2. Okay, so that's actually the right name. This one is one you have to memorize is permanganate, and it's MnO4 minus. Okay, and so if you have 2 of them, that means you have a -2, and then magnesium is +2, so that's magnesium permanganate. So both the formula and name are correct. This one, manganese 2 nitrate, so similar to this first one, except now this is nitrate. Okay, so that's also correct. And then this one is also nitrate, magnesium nitrate. Again, that's a -1 charge. You have 2 of them, so magnesium is +2. So, formula and name are correct. This one, though, is incorrect. It really should be magnesium nitride. Okay, nitrite means this one. Okay, so nitride, it means just a nitrogen. Okay. Which isotope is not possible? So, well, I think we already looked at this first one in class, so that's fine. That's also another isotope of hydrogen. Here's another one for hydrogen. Okay, so all those are fine. Let's look at this one. So chromium, element 24. So that matches, and then it's got a mass number of about 52 here. And so, 52, 24, those look right. Okay, so that's a possibility. Now this one, manganese, and then the bottom is 54. And so let's look at manganese, and no, the bottom number should be 25. Right, the top one should be 54, 55. Okay, so these numbers are flipped. Right, so they should be that way. Okay, so that's not possible. Now, which has the same number of sig figs as this? So this has 1, 2, 3, 4, 5, 6 sig figs. And so this has 3, that has 1, that has 1-ish. It's kind of ambiguous, but we generally would say that has 1. This has 4, and so the only one with 6 sig figs is that one. Okay, and then which does not represent an element, so that's a compound, right? That's hydrogen fluoride. So all these other ones are elements. Remember, you have some elements that are diatomic, like hydrogen. Remember, there's 7 of them, and it forms a little 7 in the periodic table. So hydrogen, and then it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Okay, so all of those, as elements, they are diatomic. Okay, so this would be oxygen. Okay, just like Cl2 would be chlorine, etc. Okay, and then all the other elements are just the symbols from the periodic table. Which is chemically similar to magnesium, so that means which are in the same group as magnesium. And so the only one in that list is calcium. Okay, right there. Which is a good conductor of electricity, which means a metal. Okay, and so all these are non-metals. And so iron, as you know, is a good metal, a good conductor of electricity. Which is chromium-3 oxide. So chromium-3 and an oxide is that. And so putting them together to balance out the charges, we're going to need 2 of these and 3 of those, so that we've got like a -6 and a +6. So that's Cr2O3. Intensive property. So this is something where it doesn't matter how much of something you have. Okay, so sample size it's independent of that, and so temperature would be the only one of these. Like mass, it depends. The volume, it depends how much. The amount, the heat content. Okay, like a glass of water will hold less heat than the Great Lakes, for instance. Okay, it's a huge heat sink. Okay, and that varies. The climate around that, or the weather patterns around the Great Lakes, are very different than other places because of that. Okay, so temperature is the only one where that is intensive. Okay, so I hope that helps. As always, let me know if you have any questions about any of these, but that is all for the video. Thank you.